Descartes studied law in college because his dad wanted him to. After that, he gave up for a while on books and decided to see the world. He had a practice of lying in bed and thinking, including about mathematics. He had lots of great ideas in math and in philosophy. We're going to focus on just one. The story goes, he had an idea while lying in bed and looking at a fly on the ceiling. He noticed that he could describe the location of the fly by two numbers. That is, the distance of the fly from two walls making a corner. And he realized that this works even when the walls were not necessarily perpendicular. This led him to understand that he could formulate geometric questions using algebra. Now, the walls play the role of what we would now call axes, and the two numbers are called coordinates. The coordinate representation of a vector v in terms of other vectors a1 through an is the vector of coefficients, the vector of numbers alpha 1 through alpha n, such that v equals alpha 1 times a1 and so on, up to alpha n times an. In this context, we call the coefficients, the numbers in this vector, coordinates. For example, this vector can be written as this linear combination. So its coordinate representation in terms of these vectors is the vector of coefficients, 1, 2, 3. So that's its representation. What's the coordinate representation of this vector in terms of these vectors? Well, we can write this vector as this linear combination. So the coordinate representation is the vector consisting of the coefficients 2, 2, and minus 1. Here's one more example. What's the coordinate representation of this vector in terms of these three vectors? Here we've expressed this vector as a linear combination of these vectors. The coefficients are 1, 0, and 1. So the coordinate representation is the vector 1, 0, 1. Now, why are we going around putting coordinates in a vector? It makes sense when you think about the linear combinations definition of matrix vector multiplication. So let A be the matrix whose columns are the vectors a1 through an. Then when we say U is the coordinate representation of a vector v in terms of a1 through an, we can rewrite that as the statement that A times U equals v. So to go from a coordinate representation u to the vector being represented, say v, we multiply A times u. I call this rep to vec. Now, to go from a vector to its coordinate representation, we have to solve a matrix vector equation. We have to solve A times x equals v, and the solution is a coordinate representation.